Welcome back to the Working Thesis. Over the past 7 episodes, we have essentially been playing mechanics in a garage. We took apart the brain in a jar, which is the LLM, and we took apart the body, which is the harness. We looked at the durable memory, the tools, the agentic loop, and how they all fit together. But if you step out of the garage and look at the actual landscape right now, as of 2026, it is an incredibly crowded room.
It really is. If you are a developer or just tech curious, you have new tools flying at you from every direction on a weekly basis. You might be asking yourself, which one of these do I actually use? How do I even categorize them? There are dozens of them, and the marketing language makes them all sound like they do the exact same magical things.
Exactly. So today, we're going to map the territory. We will look at who is building what, how they are surprisingly similar under the hood, and we will share a true story about why you need to verify absolutely everything these tools tell you. We need a map because the noise out there is deafening, and you need a mental framework to filter it out. Let's dive in.
Quick, honest note before we dive in. This is an education series, not advice of any kind. We are just two curious people trying to make AI make sense.
And AI moves fast, so everything here is how things work as of 2026, and it will keep changing. Treat it as a map, not gospel. The real learning happens when you go and try it yourself.
The absolute easiest way to split the landscape right now is into two distinct buckets, open source and closed source. And when we say open source in this context, we mean you can actually go read the code for the harness yourself. The brain in the jar might still be a cloud model, but the body is transparent.
Right. On the open source side, you have things like the Codex CLI from OpenAI. And to be totally clear on this point, the cloud model driving it is closed, but their CLI harness is licensed under Apache 2.2.0. It is completely open source. Then you have the Gemini CLI, OpenCode, Aider, Klein, Goose, OpenHands, Continue, QuenCode, and Hermes. You can literally open up GitHub right now and read exactly how these harnesses are built.
Then you have the closed source bucket. These are the highly polished commercial products that are heavily integrated into your IDE or operating system. You have the GitHub Copilot CLI, Claude Code, Cursor, Windsurf, and Devon. You cannot see their source code, but they are incredibly popular, heavily optimized, and they often abstract away a lot of the setup for you.
The interesting thing is that despite this divide, despite the different business models and the walled gardens, they're all essentially trying to solve the exact same foundational problem. How do we take a stateless brain and give it a reliable set of hands to manipulate a codebase?
And that brings us to what we call the convergence thesis. Despite the fact that there are dozens of these tools built by fiercely competitive teams all over the world, they have largely standardized on a shared grammar. It is like watching the early days of the internet all over again, where disparate systems slowly converged on HTTP.
It is fascinating to watch. Whether you are looking at a scrappy open source project or a massive commercial tool with $1 billion valuation, they all use an agentic loop. They all use tool calling to interact with the environment. They all rely on Markdown instruction files, like the AGENTS.md family we talked about, to set the ground rules for the session.
Exactly. And they all use MCP, the Model Context Protocol, to talk to external systems and databases. They all implement skills, subagents, hooks, and context compaction. The specific terminology might vary slightly from vendor to vendor, but the architecture has fundamentally converged. The industry has basically agreed on what a harness should look like.
Which is fantastic news for developers. It means we are not dealing with a fragmented ecosystem where every single tool requires a completely different mental model. The concepts are universal. If you know what a tool call is in Aider, you know what it is in Claude Code. Because they have converged on this shared grammar, a beautiful thing happens. If you learn how one of these tools works under the hood, you largely understand them all. You do not need to memorize the documentation for 20 different agents.
This is exactly why we spent so much time on the fundamentals in the earlier episodes. If you understand our core rule, that the model sets the ceiling and the harness sets the floor, you can look at any newly released tool and immediately reverse engineer its architecture in your head.
You stop seeing them as magic black boxes that write code for you, and you start seeing them as specific implementations of the same basic loop. You can look at a new tool and say, they are using a standard tool calling loop with a specific markdown prompt and a particular way of doing compaction to save tokens.
It is incredibly empowering. You are no longer just a passive consumer of these tools. You are an educated operator. You can swap the brain, keep the body, and know exactly what is happening at every step of the lap. You know when the harness is working well, and you know exactly why it fails when it breaks down.
Now, because we are educated operators, we know that these tools are not infallible. The brain in a jar is still a statistical engine. And that brings us to a true story about a crucial lesson in grounding.
Yes. Recently, I was doing some research on a popular CLI tool for a project. I was using an AI web search agent to gather context quickly, and the agent confidently claimed in its summary that this CLI was MIT open source. It presented it as an absolute, verifiable fact.
Which sounds great, right? If it is MIT licensed, we can fork it, modify it, and use it however we want. But because we know how these brains in a jar work, we know they can hallucinate details that look statistically plausible. So we did what you should always do. We went directly to the primary source. We checked the actual repository.
And what did we find? The repository only contained an installer script and the documentation. All of it was licensed under a custom proprietary license. The real source code for the CLI was not public at all. It was completely closed source.
To be very clear here, the vendor was not being deceptive in any way. They were perfectly transparent about their licensing on their website. The hallucination came entirely from the AI web search agent. It associated CLI tool with open source in its neural weights, and it just made up the MIT part out of thin air because it sounded right.
This is the exact same grounding skill we talked about in episode 6, but applied to us humans. AI summaries hallucinate. You have to verify them against the primary source. Trusting the summary without checking the link is a recipe for disaster.
The brain in a jar is a prediction engine. It is predicting what words should come next based on vast patterns in its training data. Sometimes, the most statistically likely pattern is factually wrong. It is our job to provide the grounding, just like the harness provides grounding for the agent during a coding task.
This is why the harness is so critical for the agent, and why your own verification is so critical for you. The harness uses tools to ground the model in reality, reading a file, running a test. You have to use your own tools, like actually reading the repository license file, to ground the AI's claims.
Trusting an AI summary without checking the source is exactly like running code without testing it. It might work 9 times out of 10, but when it fails, it will fail spectacularly, and you will be the one responsible for the fallout. So why does all of this matter for you, the developer sitting at home in 2026? It matters because the landscape is only going to get more crowded and more noisy.
You are going to be bombarded with aggressive claims about new models, new harnesses, and revolutionary new paradigms. But if you understand the convergence thesis, you can cut right through the noise. You can evaluate these tools based on their underlying architecture, not their marketing copy.
And if you internalize the lesson about the grounding save, you will never be caught off guard by a hallucination. You will use these tools as massive amplifiers for your own intelligence, not as blind replacements for your judgment.
You become the ultimate supervisor of the agentic loop. You set the rules, you verify the outputs, you maintain the context, and you reap the incredible benefits of the automation without falling into the traps.
Let's recap. The landscape is currently divided into open and closed source, but underneath, they have all converged on a shared grammar. If you learn one, you truly understand them all. And most importantly, always verify AI claims against the primary source.
The model sets the ceiling, the harness sets the floor, and you set the standard for truth.
Exactly. But there is one specific, highly technical design choice within the harness that drastically changes how everything works. It is a choice about how the agent actually delivers an edit to your code.
In episode 9, we are going to read the source code to understand that specific choice, because it is the one choice that changes everything about which models you can use. See you then. And that is a wrap for today. If this made AI feel a little clearer, do us a favor and subscribe. It genuinely helps more curious people find the show.
We are learning and building with AI right alongside you, one episode at a time. So hit follow, and we will see you in the next one.